everyone, my name is Shweta. Today I'll be presenting the topic keyword extraction. Coming to what is keyword extraction, the amount of text documents such as articles, social media posts, and publications is growing. Since we cannot read all of them, we need methods to help us find those relevant documents. Keywords or key phrases extraction methods can be of great help with the problem we are facing. Keyword extraction is a retrieval of keywords or key phrases from text documents. They are selected among phrases in the text document and characterize the document's topic. Methods that automatically extract keywords from the documents use heuristics to select the most used and most significant words or phrases from the text document. Keyword extraction methods in the field named as natural language processing, which is an important field in machine learning and artificial intelligence. Keyword extractors are used to extract words or group of two or more than two words that create a phrase. Summarizing a text is an important problem in text mining. Information retrieval and NLP tasks like automatic semantic indexing, text and document clustering or classification, automatic summarization, document management, cross-category retrieval, and constructing domain-specific dictionaries, named entity recognition, topic distinction, tracking, etc. Imagine you want to analyze thousands of online documents about a specific topic. Keyword extraction allows you to sift through the entire set of data and get the words that describe each document in seconds. That way you can easily and automatically see what your documents are about, saving your teams hours and hours of manual processing. Approach methods. I will overview some of the most used keyword extraction methods. I will consider unsupervised, which means they do not need training, and domain independent methods. These are split into statistical, graph-based, and embedded-based methods. Keyword extraction techniques are classified into supervised and unsupervised methods. Unsupervised methods, which are widely favored, do not require label training, data, and work efficiently across various domains. On the other hand, supervised methods, while achieving higher accuracy, demand label data, which often isn't readily available. Given the common absence of label data, we delve into the unsupervised domain independent methods. Within the realm of unsupervised techniques, we can further classify them into main three categories as mentioned before: statistical, graph based, and embedded based methods. These methods play a crucial role in extracting keywords from data. Statistical methods are most simplest. They compute statistics for keywords and use those statistics to score them. Some of the simplest statistical methods are word frequency, word collocation, co-occurrence. However, there are some more sophisticated such as TF, IDF, and YAKE. Statistical models offer a straightforward approach for pinpointing primary keywords and key phrases in text. Within this category, you will find various methods, including well-known ones like TF, IDF, and YAKE. These techniques have the advantage of not needing additional data to identify crucial keywords within text. However, it is important to note that because these models solely rely on statistical patterns, they may overlook significant keywords or key phrases that appear only once but still contextually relevant. TF, IDF, or term frequency inverse document frequency estimate words importance in the document relative to entire corpus set of documents. It computes the frequency of each term in the document and divided by the inverse of the term's frequency in whole of the corpus. In the end, the terms with the highest scores are selected as keywords. This is done by multiplying two matrices, the number of times a word appears in a text and the inverse document frequency, how rare or common that word is in the entire dataset. Because of this, top words that occurs a lot in the entire dataset will receive a low TF-IDF score, and the most used and the most important words will receive a high TF-IDF score. This technique, however, fails to find words that appear in a single text but don't appear in the remaining documents but are very important to understand the content of that text. TF-IDF equation, where T is the observed term, the equation is applied to each term, word or phrase in the document. The blue part of the equation is the term frequency and the orange part is the inverse document frequency. The idea of TF-IDF is that words that appear more frequently in the document are not necessarily the most important relevant. This algorithm favors terms that are frequent in the text document and not frequent in other documents. The advantage of TF-IDF is that it's fast, and the disadvantages is that it needs a corpus of at least a few dozen documents. TF-IDF is language independent. Here TF is equals to the count of T in a document divided by number of words in document. Inverse document frequency is defined as IDF is equals to log of number of documents in corpus to the number of documents where T appears. Yet another keyword extractor is a keyword extraction method that uses statistical features from a single document to extract keywords. It extracts keywords in 5 steps, that is pre-processing and candidate term identification, future extraction, capturing term solve, n-gram generation and counting candidate keyword score, data duplication and ranking. Pre-processing and candidate term identification. In this step, the text is split into sentences, chunks, that is the part of the sentence separated with punctuations and tokens. Text is clean, tagged, and stop words are identified. Future extraction is the second step involved in the process of YAKE. The algorithm computes the following 5 statistical features for words in the document. Casing, that means it counts a number of times proportional to all appearances that term appears uppercase or as an acronym in a text. A significant term usually appears uppercase more often. Second is term position, median position of the term sentences in the text. Terms closer to the beginning used to be more significant. Term frequency, normalization, measures balanced term frequency in the document. Terms relatedness to context, measures with how many different terms the candidate term co-occur. More significant terms co-occur with less different terms. Term different sentences measure how many times terms reappear in different sentences. A higher score indicates a more significant terms. Third is a computing term score. Features from the previous step are combined to a single score with the man-made equation. The curious reader, the computing score can be found from the previous step. Generating an n-gram and computing keyword scores. The algorithm identifies all valid n-grams. The words in the n-grams must belong to same chunk and must not start or end with stop word. Then each n-gram is scored by multiplying its member scores and normalized to reduce the n-gram length impact. Stop words are treated differently to minimize their impact. Data duplication and ranking. In the last step, algorithm removes similar keywords. It keeps the one that is more relevant, one with the lowest score. The similarity is computed with either the Levenshtein similarity, the Jarrow-Winkler similarity, or sequence measure. In the end, the list of the keywords is sorted based on the scores. The YAKE's advantage is that it doesn't depend on external corpus, the length of the text document, language or domain. In contrast to TF-IDF, it extracts keyword on a single document basis and does not need any large corpus. Graph-based techniques create a network of interconnected terms based on the relationships between the documents. These network, for instance, links terms that frequently appear together in the text. Graph-based methods employ ranking algorithms that factor in the graph structures to elevate the significance of individual terms. TextRank is a well-recognized example of such graph-based methods. TextRank is a graph-based ranking method that is used for extracting relevant sentences or finding keywords. I will focus on its usage in keywords extraction. The method extracts keywords with the following steps: tokenization, graph construction, graph ranking, select keywords, extract keywords. Text tokenization and annotation with the parts of speech, POS, tags, word co-occurrence, graph construction. Vertices in the graphs are words with selected POS tags. Authors achieve best results with selecting only nouns and adjectives. Two vertices are connected with an edge if they appear within the window of n words in the text. According to the author's experiments, best performing n is the graph unidirected, undirected, and unweighted. Graph ranking. The score of each vertex is set to 1 and the ranking algorithm is run on the graph. Authors use Google's PageRank algorithm, which was primarily used to rank graphs of websites. The algorithms use the equations from the image above. The weight of S of vertex at each index of a vertex Vi is computed with considering weights of vertices connected to the node Vi. In the equation, D is a damping factor set to 0.85 as suggested in the PageRank. Are inbound links to the vertex and outbound Vj are outbound links from the vertex Vj. Since we are considering unidirected graphs, undirected graphs, inbound links of the vertex and the outbound links of the vertex are the same. The algorithm is run on each node in several iterations until weight on the nodes converge. The change between iterations is lower than 0.1. Top scoring word selections. Words are sorted from highest to lowest scoring words. In the end, the algorithm selects the first 1/3 of the words. Keyword extraction. In this step, words selected in the previous phase are joined in multi-keyword if they appear in the text together. For example, consider the sentence, "She only paints with bold colors." If both bold and colors are selected as keyword, algorithms outputs bold colors as a word. A score of newly constructed keywords is the sum of the word score. The algorithm is performed on each document separately and does not need a corpus of the documents to perform keyword extraction. TextRank is a language independent. Rake. Rake automatic keyword extraction is another graph-based keyword extraction algorithm. The algorithm is based on the observation that keywords are frequently composed of multiple words and usually do not include stop word pronunciations. It includes the following steps. Candidate keyword extraction. Text is split on keywords candidates based on stop words and phrase delimiter. A keyword candidate is a phrase that is between two stop words or phrase delimiters. Phrase delimiters are, for example, punctuation characters. Keyword co-occurrence graph construction. Vertices in the graph are words. They are connected if they appear together in candidate keywords. The graph is weighted. Weight is a number of times that connected words appear together in the candidate keywords. The graph also indicates connections to the vertex itself. Word scoring. Each word in the graph is scored with one of the scores, a word degree, number of words that word W co-occur with sum of edge weights, including an edge that points to vertex itself. Degree favors words that appear more often and in longer keywords. Word frequency, number of times that word appear in any candidate keyword. Frequency favors words that appear more frequent. Ratio of the degree to frequency. This metric favors words that mainly occur in longer candidate keywords. It is suggested to use either word degree ratio or ratio of the degree to frequency from those two. The degree will favor shorter keywords. Candidates keyword scoring. The Score of each candidate keyword is sum of the scores of its member words adjoining keywords. The candidate keywords do not include stop words. Keyword extraction: as a result, 1/3 of the best scoring keywords are extracted. The main difference between rake and the text rank is that rake considers co-occurrences inside and the candidate keywords instead of a fixed window. It uses a simpler, more statistical scoring procedure. It does not include optimization. The algorithm is performed on each document separately, so it does not need a corpus of documents to perform keyword extraction. Keyword extraction has several practical applications: identifying significant terms and phrases in consumer reviews, feedbacks, and suggestions, providing valuable insights for product development, tracking social media trends, hot topics, and monitoring competitors' online activities, analyzing shifts in public opinion over time regarding a specific product's lines or services, simplifying the process of finding, organizing, and accessing relevant information to facilitate learning, automatic ticket tagging in customer support, allowing support teams to concentrate on effectively resolving issues. Tools for keyword extraction. The ByteView's keyword extraction tool can analyze unstructured text like customer feedback, email, surveys, and social media posts. You can define tags to categorize content into topics, business insights, customer opinions, and recurring issues. Cortical.io enables you to search for, extract, and analyze keywords in unstructured text. Their models can be quickly adapted to your industry-specific vocabulary. Aliens News API is a user-friendly tool used for keyword extraction, designed for analyzing text data in documents and web content. Monkeylearn is a user-friendly SaaS platform that allows you to initiate keyword extractions from various sources instantly. You can use their pre-trained model or create your own specific needs. Keyword extraction is a powerful tool for identifying relevance within extensive datasets. It empowers businesses in various industries to automate intricate processes that would otherwise be time-consuming, less efficient, or even impossible to manage manually. You have explored how keyword extraction can be done, benefit customer support, social media management, market research, and more, providing valuable insights for informed business decision. Now it's time to evaluate your data analysis by Excel by harnessing keyword extractions. Thank you so much for the given opportunity.